Welcome to our next Level 3 simultaneous equations video. This is our third video on types of equations. Now we know three-dimensional simultaneous equations have three possible scenarios. They could have a unique solution, they could have equations that are dependent, or they could have equations that are inconsistent. Now in the last video we explored two of these options. Let's quickly review them. Example 1. Solve the following simultaneous equations to determine what type of solutions exist. Well, we grabbed our graphics calculator and found it was a unique solution. Example 2. What about this pair of simultaneous equations? Well, when we grabbed our graphics calculator we got a mathematical error and we had to use algebra to create equations D and E, and when we went to do our elimination of y, it actually ended up eliminating everything, 0 equal to 0. And that was the proof that they are dependent equations. So now let's look at our third scenario. Solve the following simultaneous equations and determine what type of solutions exist. Well, again, our graphics calculator is going to spit up a mathematical error. So again, we're going to have to resort to algebra to solve it and find out what's going on. Right, here's equation A, B, and C. We're going to use the elimination method and eliminate x to start with. We only use two equations at once, so let's use equations A and B. I'm going to multiply everything in equation A by 2 so that we have the same coefficient as equation B, ready for elimination. So we're going to get 2x plus 2y plus 2z equal to 2. And I'm going to write down B underneath. And we're going to start the elimination process. 2x take 2x is nothing, that eliminates. 2y subtract negative 3y. Be careful of your integers. A negative and two negatives make a positive, so we get 5y. 2z take away 4z is negative 2z, and 2 take away 0 is 2. So this is our equation D, which we'll pop down here ready to use later on. Let's go back now and pick two new equations to eliminate x again. So I'm going to use equation A and C. Once again, I'm going to multiply everything in A by 3 because that'll give me the same coefficient as C, ready to eliminate. So we're going to get 3x plus 3y plus 3z equal to 3. And if I write down equation C underneath, we're ready for our elimination. So 3x take away 3x eliminates. 3y take away negative 2y. Again, be careful of your negatives. We get positive 5y. 3z take away 5z is negative 2z. And 3 take away 2 is 1. Well, this is equation E, and we'll pop them down here ready for our next stage of working. Right, well, we've done the elimination of x to get equations D and E. Let's move on to eliminate y. We can see that the coefficients of y are ready to eliminate straight away. Don't need to do any further algebra. So let's do our subtraction. 5y minus 5y and negative 2z subtract negative 2z. Well, both of these are going to cancel out to give us 0 on the left. However, when we turn to the right-hand side of the equations, 2 take away 1 does not give us 0. If we got 0 equal to 0, the proof is that they are dependent equations. But when we get 0 equal to some other number, 1, or something equal to something else, we know this doesn't make sense. Something's not right, and so there is the proof that these equations are inconsistent. When you get 0 equal to something else, or something equal to something else. All right, let's sum this up. For unique solutions, we know that we can find a solution for x, y, and z. When equations are dependent, we know that one or more equations are dependent on others. We would find we couldn't find them all, but there are infinite solutions. And the justification, the proof in our algebra, somewhere we're going to get 0 equal to 0. Finally, for equations that are inconsistent, they look to be dependent, but they end up being inconsistent. We end up with 0 equal to something else, not 0 equal to 0. There are no solutions for inconsistent equations, and the justification is when we get something equal to something else. Right, that's it for this video. Thanks very much.